Okay, question C. Find the intervals of concavity and the inflection points, if possible. Okay, so for concave, upward or downward, we need what? Second order derivative, right? So, where's the first order derivative? F prime of x is eventually here, right? Here. So, in order to find, okay, I'm just copy it here. Okay, I'm gonna copy it here. So this is question C. Find concavities. Okay, so f prime of x equals what? 12 minus 3x divided by 2 times square root of 6 minus x. We need to differentiate again to find the second order derivative, right? So how? Quotient rule is the only choice for us. Okay, so square the denominator, give us 4 times square root of 6 minus x squared. 6 minus x. Then differentiate the numerator. Negative 3 times by 2 times square root of 6 minus x. Okay. Minus. Keep the numerator times by derivative of this. Okay, derivative of this, okay? So we have number 2 is here. What is the derivative of square root of 6 minus x? 1 over 2 square root of 6 minus x. Then the derivative of 6 minus x with respect to x. You guys was good? Alright, let's simplify. This is the 2, this is 1/2, so we'll cancel out. This negative 1 and this negative sign can be offset, right? So I'm changing it here. Okay, let's see what we have. We should have a negative 6 square root of 6 minus x plus 12 minus 3x divided by what? 6 minus x divided by 4 times 6 minus x, right? However, you see, we want to combine them, right? We combine them. So how? We're going to multiply both top and bottom by 6 minus x. What do you think? So, we should have a, and we'll write it here so you can see, okay? Same denominator. On the top, give us negative 6 times by 6 minus x plus what? 12 minus 3x. Well, on the bottom, 4 times by 6 minus x. Right? However, what is this square root? We don't like it. We want to put it on the denominator. So let's have 4 times 6 minus x to the what? 3/2. Do you know why this is 3/2?
No.
Because this square root goes down. Okay? See? This fraction divided by this. I have a weapon. Oh, come on. So this thing will goes here. Right? So what is 4 times 6 minus x times by square root of 6 minus x? It gives us what? 4 times 6 minus x square root, what is square root of 6 minus x? 1/2, okay, easy. And then combine these two, 1 plus 1/2 give us what? 3/2. So we will not worry about these two, we're combining these two, right? And then on the top we'll have what? Negative 36 plus 6x plus 12 minus 3x. Yes. So 3x minus what? 24. 4 times by 6 minus x, 3/2. We can say square root of the cube, 6 minus x cubed. Either way, right? You guys? Okay, if this is a second order derivative, we don't have to worry about what? When f prime prime does not exist, right? Remember, when we only will worry about what? F prime prime, positive or negative. So we're going to let f prime prime equals 0. So f prime equals 0 implies what? 3x minus 24 equals 0. Implies what? X equals what? 8. Then we say, just like, when we do the first order derivative, right? We find this number, we use this number divided by root number 9, right? And then when x is less than 8, check f prime prime. When x is greater than 8, check what? F prime prime. Okay, so if x is less than 8, what is the sign for f prime prime? X is less than 8.
Negative.
We can use x equals 0, right?
Yeah, exactly.
3 times 0 minus 24, negative, right? 6 minus 0, 6, positive, right? So f prime prime will be what? Less than 0, right? Do you see that?
Yeah.
Okay. And when x is greater than 8, choose any key point. Say x equals 10. 3 times 10, 30, minus 24, positive. And here we have what? We have 10. What is 6 minus 10? Okay. Oh, we don't have to worry about it because the domain for the function is x has to be less than 6, right? So there's no case that we should worry about when x is greater than 8. So we don't have to worry about it. So on the entire domain, f prime prime is less than 0. Give us concave upward or concave downward. Downward. So on the entire domain, because x is less than or equal to 6, right? Our function is concave downward. This is not decreasing, it's concave downward. Right? So
it looks sort of like the trajectory of the baseball or something like that. Just
yeah, like a bowl face down.
Yeah.
It's like a bowl, B-O-W-L.
Yeah.
So a second derivative has different critical numbers?
Yeah, it may have different. We don't call this critical numbers. Critical numbers are only for those first derivative equals 0. We call those critical numbers. And then we call this might be what? Inflection points. Inflection number means the sign of f prime prime might change sign at when x equals 8. So we call this number might be inflection point or not. Only if the sign of f prime prime changes signs. But here we only have one side. We don't even have a x greater than 8. So x equals it is we cannot give it a name, okay? Not critical number, not inflection point, nothing. Okay?
Special point.
Yeah, special point. Yeah, it is special point.
What is the critical number we have to
Current number is 4 and 6. Okay, 4 and 6.
The local maximum, the one that
Local, we have a local maximum f of 4. Okay. Alright, so now we are gathering a lot of information, so let's try to graph it. It's a lot. It's really a lot of stuff. Okay, a lot of stuff. Alright, so let's graph this function now with all of the information we are having. Okay, so first, what is the domain for this function? 0 to negative 6. Okay, so graph it.
negative
0, 1, 2, 3, 4, 5, 6, 1, negative 2, negative 3, negative 4. You can graph, sum 1, 2, 3, 4, 5, 6. That gives us 1, 2, 3, 4, 5, 6, and so on. Alright. So, we know our graph will only shows up when x is less than or equals 6, right? Alright, so what else do we know? From the previous question, we know our graph is going to be increase and decreasing on where? From -infinity to 4, graph is increasing, okay? Or below the x-axis, we don't know, it's increasing. And then when x is greater than 4 to 6, it's going to be what? Decreasing, it says, right? Already. And f of what? This is capital F, function f, this is x. F of 4 equals 4 times square root 2 is a local maximum, right? So 4, use your calculator, compute 4 times square root 2 and give me a decimal number, please.
5.66.
5.66. So it's between 5 and 6, right? Whew. This one is going to be a local maximum. And then when x is less than 4, graph is increasing. When x is between 4 to 6, it is going to be what? Decreasing. Do you see the briefly picture already?
Decreasing and it bottoms out at 6, 0.
Yeah. Well, this is 4 and square root of 2. This is 4 square root of 2. Well, the thing is, we still have a perfect picture of it, right? So, what is the value when x equals 6? F of 6.
It does not exist, but it trends towards 0.
It exists. Because when x equals 6, we should have 6 times by square root of 6 minus 0 give us what? 6 minus 6, right?
Yes.
So 6 times 0 give us 0, right?
Yes.
So when x equals 6, y equals what? 0. Oh, we love this. If you do know what's between 4 and 6, you can try f of 5. Okay, so what is f of 5? Plug in x by 5. 5 times by 6 minus 5 give us what? 5. Okay, so x equals 5, f equals 5. Whew. See key points. Okay. You may want to know when f equals 3. Yeah, you can try 3 and get f value, fine. Or you can keep on trying something. Okay, so I would say, how about when x equals 0? Let's try some key values. What is when x equals 0? 0 times square root of 6 is what? 0. Oh, that means graph will pass through 0, 0. And how about f equals 1? I would say f of 2. Why am I choosing f of 2? Because 6 minus 2 gives us a 4. Square root of 4 can get an integer, right? So it should be 2 times what? 6 minus 2. 2 times square root of 4 is 2, right? 4, right? So 2, 4. Okay. Of course, you can try when x is negative values. So, for example, you can try x equals -3, right? And try it. So f will be negative, okay? You can try, okay? Well, it says when x is less than 4, graph is increasing, right? Increasing, where does it say, okay? Well, actually, graph is increasing, 4 to 6 decreasing, and how about concavity? The entire graph is going to be what? Concave downward, right? Now with all of these key points, can you imagine our final graph? Concave downward. Graph. It's not that bad, right? Okay. So 14 minutes.